So in this way, the lower order memory address will be available for all the 3 T state, but in this diagram, in here it is shown for 1 T state, and remaining 2 T state it is provided by the latch. Now we have completed this clock, higher order memory address, lower order memory address, and ALE signal. Now see S1 and S0. S1 and S0, see this table. For opcode fetch, S1 and S0 status signals are 1 1. So I kept these signals high, S1 1 and S0 is also 1. Before this T1 state, there was some other machine cycle. Okay, the machine cycle for some other instruction before this T1 state, and after this T4 state it may be possible that there will be some other machine cycle. Okay, so we are concentrating on this opcode fetch only right now. Now IO oblique M bar, for opcode fetch IO oblique M bar value is 0, so I kept this value 0 like this will go to 0. Okay, suppose it was high for the machine cycle which was earlier from this opcode fetch, but now when opcode fetch is beginning, then this will become 0. Okay, now we are concentrating on read bar and write bar signal. Okay, so these are the control signal. So opcode fetch is a read operation or write operation. Concentrate over here. Opcode fetch means memory is giving some data, means processor is reading from the memory, so it is a read operation. Okay, so read bar will be low and write bar will be 1. See here, read bar will be having 0 value and write bar will be having 1 value. So this read bar will go low and this write bar will remain 1 for all the time. Now important thing to notice that I have put this read bar low at this clock period. Okay, at this T2 clock period I kept this read bar low, and then nearly at the end of the T3 I put this read bar again high. Okay, now what is the reason why didn't I kept this read bar low from here? Because of the two reason. What is the first reason? First reason is that if I put read bar low at this time, it means processor is controlling the whole operation, processor is controlling the memory. So if processor is releasing this read bar signal right at the beginning of opcode fetch, it means it is asking for the data. Now once the address is released in the first T state, how can processor ask for data? That address, that particular location is not selected in the memory. Did you get this point? Once the address is released, then it will take some time for that location to be selected, then only memory will be able to transfer that data through data bus. So if processor start asking at the beginning of this, then memory will send some garbage data, and that is not of use of anything. So that's why this read bar is not kept. One of the reason is to not keep this read bar low at this first state. The another reason why this read bar is not kept low at this region, because, can you tell me what will be the reason? Because this lower order address bus is containing address at this time. So if I kept this read bar low, then this data start coming. So how this bus can have two values? One is address and one is data at the same time. It is not possible for this single bus to contain two type of values. That's why this read bar is kept low at this second T2 state. Okay, now this read bar is kept low, then it means this, you can see this line and arrow over here, this is called cause and effect. Because of this, that read bar is low, its effect is shown by this arrow, means now data is coming on the data bus. What is the data? Data is opcode, because we are doing timing diagram for opcode fetch, so data is opcode. Okay, so now because this read bar is low, that's why, because of this read bar is low, its effect is now data is carrying in the data bus. Now we keep this low for 2T state, and after nearly at the end of this T state, we put this read bar high. So now cause and effect is, because read bar high, the data bus is over, okay, because now it is not containing data, okay, and that right bar is 1 for this whole operation, okay. Now see here, A8 to A15, this bus is containing higher order memory address, okay. Now see, this opcode fetch is having 4 T state, so all other memory cycles having 3 T state. Now the fourth T state is for decoding purpose, okay. So for this fourth T state, this higher order this higher order address bus will contain unspecified value, because we are not concerned about this, because this fourth T state is for decoding purpose only. So this will be containing unspecified value, and this AD0 to AD7 will be having high impedance state, means its resistance is so high that we cannot get any current. What is the bus? Bus is a wire, and what is the data? Data is current, okay. So at this point, for last T state, this is for decoding purpose in opcode fetch. So this bus is containing high impedance state, okay. High impedance state means its resistance is so high that we cannot get any current in this, okay, according to Ohm's law, V equals to IR, okay. So R is very high, so the current R is nearly about infinite, so current will be 0, we cannot get any current, okay. Now this is over. So this T4 state is for only decoding purpose, okay. Now suppose for any instruction this opcode fetch is of 6T state, so we will draw T5 and T6 over here, and we will repeat whatever these signals are in T4 state, the same signal will be repeated for T5 and T6 state, means this clock pulse will remain same. This A8 to A15 higher order address bus will be unspecified for T5 and T6. This AD0 to AD7 will be in high impedance state, okay. This ALE will be 0, S1, S2 will be, S1 and S0 will remain 1, IO oblique N bar will remain 0, this will remain 1, and this right bar will also remain 1. So whatever was in T4 state, the same will be in T5 and T6 state. I will explain you when we will be having some instruction which have 6 T state for opcode fetch. So I think this timing diagram for opcode fetch would be clear to you. In the next lecture we will study memory read and then memory write timing diagram. Thank you.